atomic weight of boron is 10.81 and it has two isotopes, 5 boron 10 and 5 boron 11. The ratio of 5 boron 10 and 5 boron 11 in nature would be, see, there are 100% atoms, okay, out of which if I consider there are x number of boron 10 atoms which is having mass 10, okay. So there are totally, if you consider 100 atoms, okay, let it be. So for 100 boron atoms, if there are x number of boron 10, then 100 minus x number of boron 11 atoms should be there, correct? So they make it as totally 100 atoms. So mass of 100 boron atoms is given as 10.81 on an average. Mass of one boron atom on an average is given as 10.81. Out of that, this is mass of boron atom, okay. Mass of boron atom is given as 10.81. If there are 100 atoms, 100 into mass of boron, then that should be 10 into x number of boron 10 atoms plus 11 is a mass number of boron 11. Boron 11 might be 100 minus x. So average mass of the boron atom is 10x, that is boron 10 mass is 10 atomic mass units. It is found in x number plus 11, 5 boron 11 is found in 100 minus x number out of 100 atoms we are considering, divided by this 100. So out of 100 boron atoms, if x number is boron 10, then 100 minus x should be boron 11. So on an average, boron's mass is 10.81, which I have to substitute. 10.81 should be equal to 10x plus 11 into 100 minus x into 100. So if you calculate this, this will become 1081 is equal to 10x plus this is 1100 minus 11x. So this is x, this side as x goes, this will be 1081, 1 minute, this will be x, minus x comes to this side, 1100 minus 1081, x will be 19. So number of boron 10 atoms in a cluster of boron 11 and 10 is 19. So number of 5 boron 10 by number of 5 boron 11 will be of the ratio x by 100 minus x, which is 19 by 81. So that is what exactly has been asked. 5 ratio of 5 boron 10 to 5 boron 11 in nature would be 19 by 81. So looking at the options, option A is the correct answer.